Howdy once again, it's Tubalcain, your YouTube shop teacher. In a very recent video, that is tips number 619, I talked about and did a repair job on this little Brown Sharpe speed counter. And after the video was published, several people said, well, why didn't you go ahead and make a brake shoe? It's missing one of the brake shoes. I thought maybe there was a design change, but apparently someone had this apart some time ago and lost one of the tiny little brake shoes. So I'd like to make another one in this video. Okay, let's take this little beauty apart. Now I realize that some of this is a repeat from the other video. So when I take this apart, I suppose someone did this at one time and that little part just flew out. Maybe they didn't even notice it. But looking at the patent drawing, remember, and I'll try to put a clip of that at the end, I realized there was two. And if you look here, the spring goes all the way through this part, and there is accommodation here that is a little flat for two shoes, but only one shoe was present, and even this one is much tinier than the sample that I made. So you can see how somebody would have lost something like that, and maybe that's 50 years ago. Maybe it's 70 years ago. So that's what I'm going to make, but on the same principle that I made this. Okay, this is the brake drum. It's made of brass. Several people in the comments were concerned that the end of the spring would score the inside, and you can see that it did, because this little spring has been clipped off at the factory on both ends. So it's, it's rather sharp, and brass is quite soft. So that's not going to hurt anything. It's not badly damaged, but the diameter of this hole is 1/2 inch. This is a 1/2 inch dowel pin. Actually, it's a little sloppy. I'll remeasure that, but it's right about at 1/2 inch, which means that the shoe will have a radius of 1/4 inch. And I'm getting a diameter here of 500 or just a little bit over 501. It's kicking around just a little bit, but that's going to be close enough. The shoe is in the calipers here, and you can see that it is 54 thousandths thick. And now the width of the shoe, you can't go down to AutoZone or O'Reilly's and buy one of these, but the width of it is 134 thousandths, and I'm not worried about the length because that'll come out all right if I am close to these dimensions. This is 1/2 inch round stock steel, and that's going to be just perfect. It's a good fit. I've already faced the end. Now the order of operations on this is very important, because once it's cut off, there's nothing to hold on to, and it's way too small to put in a vise and work on. So well, you're going to see how I do this, but the first thing I'm going to do is to put this in the lathe, use the cutoff tool and groove it, I don't know how deep yet, but so that I get the width of the shoe, which is 134 thousandths, and if there's just a little variation in that, it's probably not going to hurt, as long as it will fit into this. I hope this shows up on camera okay, but the work is in the 3-jaw chuck. I'm on the closing. This is a cutoff tool here, And notice that I have the indicator pressing up against the Aloris tool post now. So I'm going to advance the carriage until it just touches the work. There's a lot of different ways to do this, just all kinds of ways. All right, it's touching the work. I've already done that. And so I'm on 0 here. And I will back the tool out and move it in 134 thousandths. I failed to tell you one thing. I didn't take into account originally in that film clip the thickness of the blade here, which is 3/32, which is 93 thousandths. So I had to add 93 thousandths onto that 134 for a total of 0.127. Next, I will touch off, zero out my cross slide, and I'm going to feed in a total of 100 thousandths. That's a little more than what I need, but you'll see why in a minute. And now let's take a measurement. And I'm really right at 134 thousandths. Notice that I also deburred it while it's still attached to the stem. So it's ready to cut now into the half moon shape. It's almost like a woodruff key, isn't it? Alrighty, I'm over at the Bridgeport Mill. Notice how I have the work held in the vise with 2 V-blocks on top of a parallel. You know, there's no greater luxury than plenty of C-clamps and plenty of parallels, so stock up while you can. This is about a 2.5-inch slitting saw, and it's mounted in a homemade arbor which wobbles a little bit. Came from an auction. Of course, everything I got came from an auction, but the whole idea here is that I'm going to slice off just a little half moon piece off of the work piece here. Then I'm going to cut it off, and I'm going to try to catch the piece, because it's tiny, with a magnet. I think I'll make 2, because I actually count on losing at least one. I have raised the table now until I am in contact with the paper. See how it's dragging? I'll back it out. Now, I need to raise the table. The thickness of the brake shoe, which is 54 thousandths, plus the thickness of the cutter, which is 28 thousandths, I just mic'd it, and the thickness of the paper, which is 2 thousandths. So I'm raising the table with the knee here, the knee crank, 84 thousandths. And I believe I'm ready to cut. I will be running it at slow speed, so I'm in back gear. And when we run a Bridgeport in back gear, we have to run the motor in reverse. And there it is, in all its magnificence. Okay, there it is. It hasn't been deburred yet, but it is 58 thousandths, 58 and a half, so it's a little too thick. That may not matter, but I'm going to make another one by lowering the table, what, 4/1000, 4.5/1000, and see what happens, because there's plenty of material left there just by rotating the stock. So I'm going to make another one as a backup, although this one might work, but I just soon get the dimension just so. I have rotated the work 180 degrees, and now I'm dropping the table by 4/1000, but that's not going to be discernible by you. And I'll cut off another one. I'm not going to show you that because it's the same as what we just did. Okay, there they are. This is the original one. This is the one I just made. It has a horrendous burr on it. It will be no easy job deburring that. I suspect probably at Brown Sharpe they tumbled them. This is my bell saw hone. Let's see if I can do anything with this in regards to deburring. That little hone worked great. Actually, that's the first time I've ever used it. I think I've had it for about 5 years. But there's the shoe in place. That's the one I just made. I don't have the one on this side yet. But let's see if it fits into the drum. Drum roll, please. No pun intended. Perfectly. So now I will attempt to put this back together, which will be no easy job with the tension of the spring on those two shoes. You saw me struggle with it in the last video. Let's see if I have any solution. I'd like to have a tiny little ring compressor, you know, kind of like they use on engines, but it would be so tiny, wouldn't it? You know what? You're probably thinking this only took 30 seconds and now I've got the camera back on. But no, I've been struggling with this for about 90 minutes. Half of the time on my knees and 1/4 of that looking for parts, and the other 3/4 praying that I can get this thing back together. Well, I finally took some brass tubing, which is 17/32, but it's 1/2 inch on the inside, and notice I got it tapered, so I've been struggling with that. And then I think I got it lassoed with some of this brass wire and contained enough so that I can get the darn thing back together. You wonder how those wonderful women at Brown Sharpe did it 50 years ago, but they were pretty skilled. But you know, they had a whole bowl of these little parts so that when they went flying, twang, you know, they just took another one, and then the janitor swept them up by the dustpan full. All right, I just had to vent a little bit because that was not easy, and I'm still not done. We'll see if this goes on. Well, let's see what happens here. That side's on. Yes, it's on. But now I got to get that little piece of brass wire out of there. That in itself will not be easy. There, you know, this isn't easy as you get old. You can't see what you're doing, you got no patience, hands are trembling, but it's back together with that spring in there. Now it's time for a little story. There's quite a bit of tension on that now compared to what there was. Quite a bit more drag. It helps so much to have the right tools for a job, and they often have designed or built either in the shop or purchase tools for assembly or whatever, or repairs. But I recall being, 18 years old. I'm in junior college. I got this 51 Buick. You've seen a picture of it. Got the straight 8 engine, ran just beautifully. But I needed a brake job, and of course that was in the middle of winter. So I'm working out in the snow and the gravel, and it's 20 degrees. No special tools. I got crescent wrenches. I guess that's my love for crescent wrenches. So I'm doing a brake job. I didn't even know they made repair manuals. And I just struggled and struggled getting those springs off. Nobody to help me. And then it was even more difficult getting those springs back on. I remember that pliers came around and hit me in the lip. And I was bleeding like a stuck pig, but I had to get that car fixed. And I did. So I know that's irrelevant, but that's how difficult some jobs are, and that's how you learn. Well, I guess my point on that irrelevant little story is that there are special tools made. There were brake spring pliers and brake spoons and just all kinds of tools made for the job. I did not have any, nor did I know they existed. I like that little pan of ice, and it has soft jaws. It can be tilted in 2 axes. There it is. And it's rotating fine, and I can zero it out. There's definitely more tension on this now. I can feel it where it's really tight. And it's clicking on that ratchet. I don't know if you can tell that or not. And I think earlier in the video I told you the wrong number. I'm looking at a monitor where this is blown way up, and I'm still unsure, but I think it says number 748 Brown Sharpe. That's die cast. That's zinc. I like that. I like the looks of it. And somebody wanted to argue, a lot of people argued and said, it doesn't insulate it, that's just a little washer. No, it's more than a washer, it's a bushing. So that makes this thing insulated. Can you see that? Some people like to argue. Not me. I'm going to show you that it works here. I'm not really going to demonstrate its use because that's in the previous video, but this is held in the chuck, or it can be stuck into a center hole or whatever. And then of course using your wristwatch, exactly 1 minute, how many revolutions. But why would one use that when we got a built-in tachometer? That hasn't zeroed out yet. That shows you how obsolete some things become and why they become collector's pieces. Well, hope you enjoyed the video. I know you'll never make a little tiny brake shoe like this, but you saw some of the different operations that I performed, and I hope at the very least, if not less, that it was entertaining. This is Mr. Pete saying so long for now, and I'll see you in the next video. Be sure and watch my video when available, where I talk about and feature this wonderful little model of a Bridgeport Mill. Not made by me, gifted to me. But it is absolutely gorgeous, and I will talk about it for about 10 minutes.